the constant value. Now, if you were to graph a constant, that was just a horizontal line along running parallel to the x-axis, wasn't it? And the equation of that line is y equals some value c. What would be the slope of this particular line? 0. So it has no rate of change, or the rate of change is 0. Either way. So when you're looking at all of the different notations here, don't forget, because this will come up, and this always tricks people. Every time the derivative of a constant is going to be 0, every time. Don't forget that. So for A, and now we have to watch our notation, and this is where a lot of times students lose points, and it's in the notation. If we do the derivative here, that's going to say y prime equals 0. Notice it's not y anymore, it's the derivative of y, so it's going to be y prime. The same is true for B. The notation there is going to be s prime at t equals 0. And also for C and D, f prime at x is 0. And y prime, all of this stuff here, those are all constant values. So it's going to be 0. I'm going to put another example up here because everybody always forgets it or messes up with it. If I wanted to know what the derivative of pi is going to be, now just pi, what do y'all think it's going to be? 0. Pi is just a number, right? It's an irrational number, so the answer is 0. What would be the derivative of e? Not e to the x, just e. What is that derivative? 0. Be careful with these. Everybody messes those up. If it's not on your paper, you're already behind. Put it on your paper. It's not going to crawl off that board to your paper, and if it does, you're doing drugs and you need to quit. It's bad for you. Quit it. Write it. You're not going to remember. I know. All right, now let's go ahead over here to the side where we have an xy axis, and let's sketch the line y equals x. Just plain old y equals x. Do y'all remember what that looks like? Some do, some are like, it's been a while. Looks something like that, right? And if you had y equals x, and I asked you, what is the slope of this line that you just graphed? What is the slope of it? 1. So, if that's going to be our slope, that's our rate of change. So, look at part A. What do you think the derivative of this function is going to be? 1. F prime at x is going to be 1. Okay, what about part B? What would S prime be? S prime at t is still 1. X prime at t is going to be what? 1. So if you've got just a variable and you need to find the derivative with respect to that variable, your answer is always 1. Every time. Questions? All right, let's move on. Now let's talk about the power rule. Power rule is very important and it never goes away. We will use this for the rest of the school year. Please take time to learn it. Now with the power rule, notice that they've given you a formula up here. You have this formula. Mr. Addison, if you want to keep that essay, you will put it in your binder and stop working on it, or I will throw it in the garbage. Now, let's look at let's look at A. Let's see if we can apply that formula. So here, we're going to move our exponent down to the front, and then we subtract 1 from that exponent. So y prime, that's our derivative, the notation for it, please title whatever you're about to write, it's y prime, equals, and then it's going to be 2x to the first, which is really just what? 2x. So the derivative of x squared is 2x. Now we do that because you're never asked to find the slope of a parabola, right? The graph of y equals x squared is going to be a parabola, right? We don't have a slope of a parabola. That's nonsense. But what we can do once we have a derivative is talk about an infinite amount of slopes of tangent lines, because that parabola is made up of an infinite amount of points, and if we talk about a tangent line to any one of those points, then we can estimate a rate of change at that precise moment. So that's why we need our derivatives. We need to talk about what's going on at that moment. Okay, so for part B, again, when we do our derivative, it's going to be f prime at x equals, multiply the 4 down. Now there's an understood 1 there, and we're just saying 4 times that 1. So there's 4. X to what power? To the third. We subtract 1 from the exponent. Okay? Questions? All right, now look at C. C, it does not have an exponent written there, so we're going to have to change this. Does anyone remember? Now look at the title though. I'm saying y equals, because I'm not doing the derivative, I'm just rewriting. What exponent means square root? 1/2. 1/2 is the square root, right? So we're still going through this process. So we're going to multiply that 1/2 down front. So I have 1/2 x, and now I need to subtract 1. 1/2 minus 1. A shortcut to this. You're really saying 1 minus 2 and putting it back over 2. What's 1 minus 2? It's negative 1 over 2. Quick way to do that. Now the y behind that is because if you're saying 1/2 minus 1, you've got to change that 1 to be a fraction, which is going to be 2 over 2. It always mimics whatever denominator you already have. So don't spend so much time trying to subtract those. It's the numerator minus the denominator back over the denominator, and it never changes. Now you are welcome to leave that as it is for right now, because we will eventually be plugging in values for it. So don't do anything now. Don't simplify it. Leave it just like it is. We will eventually get to the simplifying, but it'll be with numbers, and it makes it a lot easier to work with. All right, and that would be your answer for C. What about for D? It's not written as just something to an exponent. I've got to rewrite it. So how could I make 1 over x to be x to some power? X to the negative 1. Good. Because that means reciprocal, right? And I need the reciprocal of that x. Okay, now let's do our derivative. So g prime is going to be equal to, again, multiply that negative 1 down front, times x to the, well, what would negative 1 minus 1 be? Negative 2. And again, you're welcome to leave that. Okay, what about for E? How am I going to rewrite that? And I'm just calling it f of x because I'm just rewriting it. That's going to be x to what power? Negative 2. So what would f prime at x be? Negative 2x to what power? Negative 3. Questions? All right, so now let's look at f. We're going to have to rewrite that first. So we're going to have y equals x to the negative 2 over 3 so y prime equals, and again we're still multiplying that down to the front, so we have negative 2/3 x, and now I need to subtract 1 from 2/3, negative 2/3, so that's really just negative 2 minus 3, isn't it? Which that's just going to be negative 5 back over 3, and you just leave it. All right, so let's look at A. Y prime is going to be equal to, now if there's a number already sitting here, and y'all, this is true when we talk about derivatives of all the different trig functions with e to the x, you're just going to take this exponent and multiply it to the value already there. So really this is going to be 6x, isn't it? And that's it. So what did y'all put for B? S prime at t, make sure you have your notation, equals negative what? Perfect. Okay, so look at part C. We have y equals, now we do need to change that square root of x to be x to the 1/2 power, isn't it? Y prime is going to be equal to 1/2 times 6, or half of 6. Going to get 3. X to what value? What's the exponent? Negative 1/2. Very good. Okay, y'all try the next 3. Okay, so we need to rewrite part D to be 3x to the negative 2. And so G prime, hopefully we got negative 6x to the negative 3. Did y'all get that? Awesome. So for our next one, again, we have to rewrite f of x. It's going to be 4x to the negative 1/2. Is that okay? Good with the rewriting? And so f prime at x is going to be negative 2x to the negative what?
3/2.
Negative 3/2. Because it's negative 1 minus 2 is negative 3, so it's negative 3/2. Questions? Okay, so for the last one, we have y equals, that's negative 8x to the negative, does anybody remember? 4 over 3, right? So 4/3. Exponent over root every time. So y prime is going to end up being a positive 32 over 3, isn't it? X to the negative what? Negative 4 minus 3 is negative 7 over 3. So for A, finding the derivative, we're going to say f prime at x equals, hopefully we got 3x squared minus 10x plus 2. What happens to the minus 7? What's the derivative of a constant? 0. So this is it. That's your final answer. Okay, let's look at part B. Y prime equals 2x to the 4th plus 4x cubed plus 6x What happens to the minus 1? It's 0. All right, so the first thing we have to do is rewrite some of this. So we have x to the 1/3 plus 5x to the 1/2. And now we can go through and find our derivatives. And make sure you are noting that this is g prime at x. Make sure that's on your papers. And then you have 1/3 x to the negative 2/3, isn't it? And then we have plus, and that's going to be 5/2 x to the negative 1/2. Any questions about that one? All right, so let's look at part D. We have y prime equals 15 over 2 x to what power? 1/2 minus, what about this next term? 6 times 5 over 3 is really what? 10. X to the what? 2/3. Now what about this x here? That's really 4x to the negative 1, isn't it? So that's going to be negative 4 x to the negative 2. And I want y'all to leave it for right now. Just leave it alone. Questions? All right, let's keep going. So here we're going to have h prime is going to be 6x. Now that's really 4x to the negative 2, isn't it? So then that's going to be positive 8x to what power? Negative 3. And then remember that's really 2x to the 1/2. So that's going to be plus x to what power? Negative 1/2. Questions about it? Okay, so now for the next one, what we're going to do, and you can only do this when you have one term in the denominator, we're going to go through and divide up each term so that we have 8x cubed over x. And then I'm going to have plus 4x squared over x minus 3 over x. Now, only do this when there's one term in the denominator. If that was x plus 3 in the denominator, we would have to use what's called the quotient rule, and we'll be learning that tomorrow. But if it's one term, please divide it up, because then after it's divided up, we can continue to reduce this. So that's really 8x squared, isn't it? Plus 4x minus 3x to the negative 1. And I understand several of y'all could do that step in your heads, and that's fine. I'm just showing y'all where each piece comes from. So if you want to do that in your heads and not write that out, that's fine. Just be careful. And so f prime at x is now going to be 16x plus 4, right? And then we're going to have plus 3x to what power? Negative 2. Now, when you are finding the derivative of the trig functions, all you are doing, and please, 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 because this confuses the snot out of people, all you're doing is changing the trig function. You're taking out, so if I want to find the derivative of sine of x, that means I'm going to replace sine of x with cosine of x. That's all that means. You're going to take sine of x out of the problem and replace it with cosine of x. There's no multiplying by an exponent and subtracting 1. There's none of that. You're just changing out the trig function. Now, the derivative of cosine, and it's pretty good for y'all to remember this, it's really the derivative of any trig function that starts with a c is going to be negative. Automatically going to be negative. And the derivative of cosine is sine of x. And again, there's no working with exponents or anything like that. You're replacing the trig function with another function. That's all. And then the derivative of tangent of x That's going to be secant squared of x. Now make sure you put the squared on the trig function. That is not the same thing as secant of x squared. Those two are two completely different things, so be careful. Yes, ma'am.
Isn't it tangent like cosine over sine? So why would it be sine over cosine, which is
Because I could go through and show you the product rule and show you where, or the quotient rule and show you where it comes from, and we'll do that eventually. But right now, just take it for what it says, and then I'll prove it to y'all whenever we do. Yes. Yes, tangent is sine over cosine, but when you do the derivative of sine over cosine, then it gets a little more involved. You can't just do derivative of the top over derivative of the bottom. That doesn't work with division. Okay, questions, great questions. All right, so now we've got another thing that we have to keep up with in all of these rules, and that's going to be e to the x. And over on your paper somewhere, we're going to go through and review some facts about e to the x, because I know folks coming in from Algebra 2 haven't seen it, and pre-cal kids don't remember it. So we need to go back through all of it. So the first thing that we need to do, let's talk about the graph of e to the x. If we had to graph the function e to the x, we have an exponential function that does something like this. There's the graph of e to the x. The y-intercept right here is going to be the point 0, 1. We need to keep in mind some basic values of e. Now, e itself is 2.718284559. Y'all don't have to remember all that. If you'll remember that it's at least 2.71, remember that. You'll never have to write out that expansion, but I tell you this so that you have in your mind that it is just a number. So if I wanted just plain derivative of e, not e to the x, just derivative of e, yes, that's 0 because it's a number. But when we throw x in there, that kind of changes it up a little bit. Now, some things that we have to remember about this. E to the 0 power is still 1. Now let's go ahead and throw in natural log ln of x. And I'm going to swap colors here. And ln of x does something like this graphically. So the blue is f of x equals the natural log of x. This point is 1, 0. So what's happening here is that ln of x and e to the x, they are inverses of each other. In an inverse function, that just means it swaps your x's and y's. Now, pre-cal probably hadn't seen that since a long time ago. In Algebra 2, y'all talked about it, but not a whole lot. An inverse function just swaps the x's and y's. That's all it does. So if you've got e to the x, a for sure point on e to the x, you know a point on natural log of x. You just swap your x and y. Okay, now let's talk about some formulas that we could pull from all of this. Well, the natural log of e to the x is just x. You will be great if you remember this. It's so important because a lot of times they'll throw you a derivative and it's got awful ugly, and it'll simplify down very quickly if we know this formula. Also, e raised to the natural log of x. That's just x. Still, it looks intimidating, but it's really just that. And you could be asked to find the derivative of e to the natural log of x squared. Well, that just simplifies down to x squared, and the derivative of x squared is 2x. Now, something else we have to remember. Just plain natural log of e is 1. The natural log of 1, anybody remember what that is? Natural log of 1 equals, it's 0. It's on the graph right up there. It's early. You guessed correctly. It is natural log of 1 is 0. And again, I always get asked, oh God, do I have to remember all this? Yeah, I'm not going over it just because I feel froggy. If that was the case, I'd be home drinking coffee in my backyard, reading a book. Not doing E stuff. All right, now, they give you a great formula here. They tell you that the derivative of e to the x is what? They say if f of x equals e to the x, then what is f prime of x equal to? E to the x. Holy cow. That's it. Derivative of e to the x is e to the x. Okay, what does it tell you that the derivative of the natural log of x is? 1 over x. So the derivative of natural log of x, the ln just goes completely away. So it's just 1 over x. Yes, because look at the graph of ln of x. X always stays positive. It's never ever going to be negative. It's not over on the other side. All right, kiddos, I want you to write in. Now, this is great and wonderful, but we don't always just keep good old little old x sitting up there because, you know, that would just be far too easy. So I'm going to use the family-friendly S word called stuff. You may use whatever S word you wish. But what we're going to do is talk about the derivative, and we're going to call this e to the stuff. And y'all, if you learn it going this direction, when we undo it, it's going to be super easy. The derivative of e to the stuff is going to be stuff prime. In other words, derivative of the stuff times e to the stuff. Stuff prime times e to the stuff. We are also going to talk about the derivative of natural log, but instead of x, guess what I'm going to call it? Stuff. One year a kid yelled out the other S word. Like, no. All right, natural log is stuff. If we're doing the derivative of that, it is going to be stuff prime again. That's why these are always coupled together. Stuff prime back over stuff. Stuff prime over stuff. That's going to be the derivative of the natural log of stuff.
Stuff prime, does that mean
The derivative of stuff. Stuff prime is derivative of the stuff. All right, let's apply this to A. Let's do some applications of it. Okay, so A, and this is why we do that. They tell us to use the laws of logarithms. Do y'all remember all those laws of logarithms? Heck no. That's why stuff prime over stuff comes in pretty darn handy. All right, so over here, we know that the derivative of the natural log of stuff, we just said, was stuff prime over stuff. What is the stuff in this problem? It's x cubed, absolutely. Notice natural log. Stuff. Right there it is, right? We found it, right? All right. So f prime of x is going to be equal to stuff prime. So what's the derivative of x cubed? 3x squared back over stuff. What was the stuff? X cubed. Do you see ln anywhere in that derivative? And you're not going to. It disappears. It's magic. All right. Questions about it? All right, now for B, I'm going to rewrite this because if you're multiplying with logarithms, you can separate that by addition, but nobody remembers that, and that's okay. I'm going to separate this out for us. Okay, so g prime of x. Locate the stuff. Right there's your stuff, right? So what is stuff prime? 2x back over the stuff, which was x squared, plus, now if we remember what I just wrote over to the side, this is going to be pretty easy to take the derivative of. What's the natural log of e to the x equal to? X. So all of that's really just good old x. And what's the derivative of x? Oh, let's go back. Go back to the second little section. It's 1. Derivative of x is 1. Do I want y'all to simplify any of that? No. I want to see the derivatives. All right, y'all do C, and then I'm going to rewrite D for us. Y'all try C. Stick with me. All right, so natural log of x. Find your stuff. Did y'all find your stuff? Yep, stuff's right there, isn't it? So what's the derivative of x? It didn't change from the previous problem. Derivative of x is what? 1 over stuff. So there's stuff prime over stuff, right? Now minus, 1 over x. That's really x to the negative 1, isn't it? Oh my, we've mixed all that together, right? And so whenever we do that, we're going to multiply down. So really that's going to become positive x to what power? Negative 2. Is that okay? All right, let's go through D, and I've rewritten D. I've expanded it because, again, they're wanting us to remember that if we're multiplying, we separate that by addition, and if we're dividing, we separate that with subtraction. Okay, so I went ahead and I did that part for us. Now, when we do our derivatives, y prime, okay, well, what do you think the derivative of the natural log of 2 is? Oh, I think I heard somebody say it. What's it going to be? What do y'all think it's going to be? Just think. 0. Why 0? because that's just a number, right? Natural log of 2 is just some decimal crap. So it's going to be 0 plus natural log of e to the x. All of that reduces to be just x. And what's the derivative of x? 1 minus natural log of 3x. Find the stuff. Find the stuff. So stuff prime is what? What's the derivative of 3x? 3 back over the stuff, which is 3x. Is that okay? Now, let's go back. I just thought about, you could still use that stuff prime over stuff right there. Still use that there if you want to. What's the derivative of 2? What's the derivative of 2? 0. So wouldn't that be 0 back over 2, which is 0? So you can do stuff prime over stuff there. I just look at it as a number and go on. But you can definitely do that there.